Crikey, mate, those are some big circles. We're going to be talking more about circles today in our notes. So we're starting chapter 11. Here we go. Okay, guys, so here's what your 11 notes should look like. 11.1 is parts of a circle. This should be something you've probably learned before in the past at some point, but we're going to go over it again today and start this new chapter. So a circle is a special type of geometric figure. All points on a circle are the same distance from a center point. Sorry, I sneezed. Bless me. All right. So here we see that this point is the same. This point's the same distance from O, and this point's the same distance from O. So even if I did this and labeled it Z, it'd be the same distance as B and A. All right. Note that a circle is named by its center. So this image right here would be circle O. This one down here is circle K. Circle K. Circle K. Okay, y'all see that? So we have three main terms. We have a radius, chord, and diameter. A radius is a segment from the center point to a point on the perimeter of the circle. A chord is a segment touching the perimeter of the circle but not the center. And the diameter is all the way across the circle through the center point. So down here, we need to name each of the following based on this image. So a chord, I know it's not touching the center, so AD is going to be my chord for this one. My diameter, I know it goes all the way across from perimeter to perimeter of my circle through the center, so AC is going to be my diameter. Okay, and then radius is the center to the perimeter segment, and it's going to be BQ. Okay, all right, so now down here it says, suppose the radius of segment PQ of circle P is 5 centimeters long. So I'm going to write that in so we know, 5. So the radius of PT, so radius PT is also 5 centimeters long. Okay. Then the diameter QT, this longer one right here, is 5 plus 5 or 10 centimeters long. Notice that the diameter is twice as long as the radius. This leads to the next two theorems. So the first one, all radii, meaning multiple radius, of a circle are congruent. So this radius is congruent to this radius, is congruent to this radius, is congruent to this radius, all right, of the same circle. The second theorem, the measure of the diameter D of a circle is twice the measure of the radius R of the circle. So we have this formula or this formula. All right. Okay. Now we're going to turn the page. Okay. In circle T, CD is a diameter or 2 radii. If CD is 42, this whole thing, find TC. That's TC. Okay? It wants us to find that, so I'm going to make that X. Or we could do R for radius. All right, so let's look back really quick at these two formulas we have. I know my diameter, and I don't know my radius. So I'm going to use this one and then solve for R. So I'm going to change the x to an r just so we keep it simple and we know it's radius that we're looking for. So I have diameter equals 2r. I know my diameter. It gave it to me. 42 equals 2, and I don't know r. So I'm going to get r alone. I'm going to divide by 2. R equals 42 divided by 2 is 21. So I know my radius, or TC, is 21. All right, the next one. In circle T, segment TM is a radius. This right here, I'm going to use a different color for this one. Radius. If TM is 15.5, find CD. So I'm going to actually use this one again. Diameter equals 2 radius. I don't know my diameter. That's what it wants me to find. It wants me to find this. And we know the theorem, all radii are congruent. So whatever this is going to be the same as this and the same as this. And we know diameter is just 2 radii combined. Okay? So I have diameter I don't know, 2, and I'm given 15.5. Make sure you put it in parentheses, okay? (15.5) times 2 is 31. So my diameter, or CD, is 31. See that? All right, now the last one is going to be like an algebra type problem to solve for what we're looking for. I'm going to use another different color. I'm going to use green. So it wants us to find the measure of radius PC. If PC is 2x, it told us that, and AB is this one right here, 6x minus 6x minus 28. So I'm going to label my parts. So R is 2x, and the diameter, I'm told, is 6x minus 28. So I think the easiest one to do is this D equals 2R again, because I don't have to worry about fractions. So I'm going to start filling stuff in. So I have D equals 2R. My diameter is 6x minus 28 equals 2, and my radius is 2x. So I'm going to distribute the 2, and now I'm going to work to get x alone. So I'm going to subtract 6x. I get negative 2x equals negative 28. Divide by negative 2. Two negatives make a positive. So I have 14 equals x. And if you guys get a negative answer for any of these problems that we're working with shapes, you know it's going to be wrong. We can't have negative lengths, okay? So I have x is 14, and it wants me to get this length. So I need to plug this back in up here to get the length, okay? So 14 times 2, 28, so that equals PC. If it asks you to find the diameter, we could just do 28 times 2, and that'd get us 56 as our diameter, or AB. All right, doesn't ask you to do that, but just to show you, once we know the radius, we can solve for the diameter because we know diameter is 2r. This is a pretty basic concept for this chapter. Goes into a little more trickier stuff, but this homework should be pretty simple for you guys. If you have questions, email us. We will see you on Zoom tomorrow to go over this assignment. Keep up the good work, guys. See ya.